Hello children. So now that we have seen the theory of this inverse trigonometric function, we have seen what is inverse trigonometric function, we'll get into the problems. Now we are seeing the initial level problems where only the first property of inverse trigonometric function is used, and then we are going to see the properties of inverse trigonometric functions later on. Let's see the lower level problems of inverse trigonometric function. And when it is coming to the problems in this chapter, I shall do every other problem because this chapter problems are extremely important for the calculus part. All the formulae of trigonometry is very important. So in the next class, I shall make you write a gist of trigonometric equations, or I think I can do even now. We'll finish this exercise and I'll give you the gist of all the trigonometric formulae so that you can keep it permanently with you. All the trigonometric formulae which you have learned in 11th standard, and that incorporated in this inverse trigonometric function. Again, these both trigonometry and ITF functions, ITF will be incorporated in differential calculus, and this comes in all parts of calculus, integral calculus also, differential calculus also. Further, all these will be carried on to your higher studies. So this is one of the basic things that is required for calculus. Okay. So I shall be doing every other problem. Please practice on this. Be perfect in this. We'll go to the find the principal value of sine inverse of 1 by root 2. See, when they ask you the principal value of sine inverse 1 by root 2, basically you should be writing all the values from your standard angle table. Sine inverse, the inverse trigonometric function has a number inside. Your answer has to be an angle, and the angle preferred will always be a radian here in this chapter. Don't write it in degrees. Even if you calculate in degrees, do the calculation in degree, but write the answer in radian. I have the first problem, and this is the example problem. Sine inverse of 1 by root 2 is equal to, what angle of sine is equal to 1 by root 2? It is 45 degrees. So pi by 4. This is all the answer is. And then the second question, principal value of cot inverse of minus 1 by root 3. As we have seen the first property regarding this minus things, let me write sine inverse of minus x is equal to minus sine inverse x. The reciprocal of sine inverse x is cosecant inverse. That also will be minus coming outside. It is only minus cosecant inverse x. Next, let us write for cos inverse. Cos inverse of minus x is equal to pi minus cos inverse x, because we are getting into the second quadrant where cos is negative. And then similarly, the reciprocal of cos is secant inverse of minus x. Also will have pi minus secant inverse x. And the last one, tan inverse of minus x is as good as your sine, only the minus comes outside, minus tan inverse x. Now these three are based on the formulae. Sine of minus theta is equal to minus sine theta. Cos of minus theta is straightly only cos theta. But then I want this minus to be tackled here, is it not so? I shall write where the cos is negative, that is in 180 minus, that is second quadrant cos is negative. That is why we get cos inverse of minus x as pi minus cos inverse x. Tan inverse of minus x is minus tan inverse x, and the difference here is cot inverse of minus x also will have pi minus cot inverse x. We don't write minus cot inverse x just because it is the reciprocal of tan. So why is it so? We have already dealt with this. Pi minus cot inverse, pi minus comes in 3 functions, and directly the minus comes outside for 3 functions. So which are all the functions that you have pi minus? For cos inverse of minus x, for secant inverse of minus x, and for cot inverse of minus x. You have pi minus. So let that be points be as it is. We'll complete the problem. So cot inverse of minus x will be pi minus cot inverse 1 by root 3 is equal to pi minus cot of what degree is 1 by root 3? It is 60 degree, that is pi by 3. That's equal to 3 minus 1, that is 2 pi by 3. Okay, cot inverse of minus, when you should use pi minus. And this step is not necessary if you have got used to it. if you know already pi minus cot inverse of 1 by root 3 will come over here, you can directly write pi minus pi by 3 and calculate it as 2 pi by 3. Okay, now let's go to our exercise problems which are based on this property with the minus thing. We'll go to exercise, deal every problem with that, and it should be just like one line answer. So let us start writing the first question. You have, so it should be 6 lines answer, children. Sine inverse of minus half. If you have sine inverse of minus x, minus comes outside. So minus, and then write sine of what degree is equal to half. Sine of what degree is equal to half? It is 30 degree. So I'll write the answer. It is pi by 6. We are done. I don't want you to write minus sine inverse half and that's equal to minus pi by 6. Be quick. Learn directly. Learn to write it faster and simpler way. Next I have second one as cos inverse of root 3 by 2. Okay, cos of what degree is equal to root 3 by 2 should be written here only so much. So cos of what degree is root 3 by 2? 30 degree once again. So that is pi by 6. Next I'll go to question number 3. Your question number 3 is cosecant inverse 2. Okay, I shall tell you about the reciprocals. Cosecant inverse, if you can write it as sine inverse, this 2 becomes 1 by 2. So you can directly write the answer, or you can convert that into sine if you want to be comfortable with only sine cos. If you think you are comfortable only with sine cos and tan, convert the functions secant, cosecant and cot into cos, sine and cos, secant and not cos. The secant should be converted as cos and cosecant should be converted into sine. Cot should be converted into tan if you think you are comfortable with sine, cos and tan. So cosecant can be done as sine inverse, then this 2 becomes 2 by 1 becomes 1 by 2 and now directly write the answer. This is for 30 degree, so it is pi by 6 once again. Next we'll go to question number 4. Your question number 4 is tan inverse of minus root 3. So minus tan of what degree is equal to root 3. We tackled with minus and then tan inverse of root 3 is what is remaining. So tan of what degree is equal to root 3? It is 60 degrees. So it is minus pi by 3. Question number 5. Cos inverse of minus half. Okay. If you have cos inverse, you are going for pi minus cos inverse x. Now, in the first problem when I did that example 2, I did pi minus cos inverse of something. So now I'll skip that step. I'll write pi minus because I have minus. Then cos of what degree is half? It is for 60 degree. So this is pi by 3. And that's equal to 2 pi by 3. Cos inverse of minus half. Cos, this is for half is for what degree? It is for 60 degree, pi by 3. So it is 2 pi by 3. Let me go to the previous one. I think I made a mistake over there. Cos inverse of minus, that was cot inverse of y. Okay. No, we have done correctly. Okay. Cos inverse of minus half. That was cot inverse. But both cot inverse as well as cos inverse we will have pi minus. So I got 2 pi by 3. Next we go to question number 6. Question number 6 is tan inverse of minus 1. Once again I shall write directly minus tan of what degree is 1? It is pi by 4, minus pi by 4. So we are done with these 6 questions. So you have this one chota exercise. So simple it is. Now we'll go to question number 7 we have. So I shall retain those points of the first property with the minus things. And we'll continue with our question number 7. You have question number 7, that is secant inverse of 2 by root 3. Secant inverse of 2 by root 3 is, I shall convert the secant to cos, then this becomes cos inverse of root 3 by 2. So cos of what degree is equal to root 3 by 2? You are supposed to write in radians. So cos of what degree is equal to root 3 by 2? It is 30 degree. So it is pi by 6. Next I'll go to question number 8. Question number 8 is cot inverse of root 3. If I want to convert cot as tan, this root 3 by 1 will become 1 by root 3. Tan of 30 degree is equal to 1 by root 3. So I wrote 30 degrees now, pi by 6. Next. Question number 9. Cos inverse of minus 1 by root 2. If you have cos inverse, once again you should go for pi minus. So pi minus cos of what degree is 1 by root 2? Pi by 4. So that's equal to 3 pi by 4. Next I have question number 10. Cosecant inverse of minus root 2. Cosecant is the reciprocal of sine, and inside sine, okay, let me come here. Cosecant inverse of minus x is equal to minus cosecant inverse x. So keep minus outside, and cosecant of what degree is equal to root 2? It is sine inverse 1 by root 2, so 45 degree, so it is pi by 4. Minus pi by 4 is the answer. And then that we have finished 7, 8, 9, 10. We have only 2 more to go to complete in this chapter. We have maybe another 2 objectives. Let's see. Okay. Question number 11. Tan inverse 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. Cos inverse of minus 1 by 2 plus sine inverse of 1 by 2, it is based on the theorem, the pi by 2 theorem. So now we also know sine inverse x plus cos inverse x is equal to pi by 2, and secant inverse x plus cosecant inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. You should use this efficiently. You know, there are determinants problems which really are coming with sine inverse and cos inverse. It was the CET 2018 as well as 2017. Both the years they had given the paper. They had given us the same question, which involved one matrix with sine inverse, the other matrix with cos inverse, and they had asked you to, I think the other matrix with minus cos inverse, they had to subtract. When you subtract, you will get sine inverse plus cos inverse x, and that you should know that it's equal to pi by 2. So this theorem is very important. Wherever you get a chance of using this theorem, you should be able to use it, so that you will be saved with the number of steps and also the time. See, cos inverse of something plus sine inverse of the same thing will be equal to pi by 2. If this is minus half and this plus half, it cannot happen. Okay. So now tan inverse of 1, that's equal to pi by 4. Tan of what degree is 1? Pi by 4. Sine inverse x plus cos inverse x will be equal to pi by 2. So I got the answer. LCM is 4, and so this will be pi and this will be 2 pi. So the answer is 3 pi by 4. Okay. And now let's go to question number 12. Question number 12 is again the usage of pi by 2. But do you think you can write directly? You can use the theorem inside this problem, provided you can split the 2 sine inverse. You have cos inverse 1 by 2 plus 2 sine inverse 1 by 2. The idea is to write this 2 as 1 plus 1. So I can write this as cos inverse 1 by 2 plus sine inverse 1 by 2 plus sine inverse 1 by 2. So again, using the theorem, sine inverse x plus cos inverse x is equal to pi by 2. This much is pi by 2. And sine of what degree is equal to 1 by 2? That is 30 degree. 30 degree is pi by 6. Okay, LCM is 6. This 90 plus 30, it is going to be 120. Okay, so LCM is 6, and this will be 3 pi plus pi, which is equal to 4 pi by 6. 4 pi by 6, which is equal to 2 pi by 3. Okay, see, if I have to do very faster, this is how I do. I'll do 90 degree. 90 plus 30 is 120. 120 is nothing but 2 pi by 3, because pi by 3 is 60, 60 into 2. Else you do not know directly to write in the degree, you can do this way, writing step by step. Okay, now that we have completed question number 12, we go to the last 2 problems of this exercise, where you have the options. Sine inverse x is equal to y, question number 13. Sine inverse x is equal to y. Then they are asking the answer for y, and now in this function chapter, children, you are going to adopt your domain and range understanding. Okay, see, if they are asking for x, which means that what all values you can put for x to get the answer y. And as I've explained to you before, what all the answers values you can put for x, it is called as the domain. And after putting all this domain value, what all the answers come out, that's called as the range. So now here, what all values can I put inside sine inverse? Inside sine inverse, the values is always the real numbers. So real numbers for sine is from -1 to +1. We have learned from the table like that. And now for y, when you put from -1 to 1, what is y equal to? So this implies y belongs to the closed interval -pi/2 to +pi/2, because sine inverse -1 is -pi/2, sine inverse 1 is pi/2. So all my y values ranges between -pi/2 and +pi/2. Where do you have the answer? It is with, along with, equal to. So B option is the answer. We have equal to also, there is not, here you don't have equal to. So the answer is exactly B. So now coming to question number 14. Question number 14, very, very important problem. Question number 14 is, you have tan inverse √3 minus secant inverse of -2. What is this equal to? Let's do slowly. Tan inverse √3, tan of what degree is equal to √3? It is 60 degree, so pi/3 minus, I'll open the brackets, you know why. What is secant inverse of -x equal to? It is pi minus secant inverse x. I am not going to write the secant inverse of x. Instead, I'll calculate and do for what degree it is. So I'll write pi minus, and secant of what degree is equal to 2. Or in the other way around, cos of what degree is equal to 1/2. Cos of what degree is equal to 1/2 is 60 degree. So this also will be 60 degree. 60 degree in the sense pi/3. So I shall take minus inside. You have pi/3 minus pi plus pi/3 is equal to 2 pi/3. 1 pi/3 plus pi/3 is 2 pi/3 minus pi. So you got the answer minus 3 pi. 2 pi minus 3 pi is minus pi/3 is the answer. Okay. So now that we have completed exercise, this is 2.1, correct? Exercise 2.1. We have properties of inverse trigonometric functions, where you need to, I told you directly actually, sine reciprocal is cosecant, cosecant reciprocal is sine. So you can write sine inverse of 1/x is equal to cosecant inverse x, or vice versa of that. Similarly for others. So we have certain properties of inverse trigonometric functions where you have to tackle with your minus and plus. So how did we get all this? I gave you this property which I had explained you before, that you get like this. But how are you going to prove all this? They may give you sometimes for proof. Let us see how we got all this. We have the properties goes like this. Yes. And I also want to tell you something about the conditions. See, whenever they give you any kind of proving in inverse trigonometric function, they always give you, so let me write the heading as properties of ITF. See, the first property goes like this, and I shall tell you sine inverse x, sine inverse 1/x is equal to cosecant inverse x, x greater than or equal to 1 or x less than or equal to -1. And in this you have, secondly, cos inverse of 1/x is equal to secant inverse of x, again x greater than or equal to 1 or x less than or equal to -1. And third one is about tan inverse of 1/x. I think the next one you should be able to gauge by yourself, which will be cot inverse of x, and for this x is greater than, it is greater than 0. We never say equal to 0 because it will become 90 degrees. Okay. So see, tan inverse of 1/x equal to cot inverse x. Now these conditions are also important in inverse trigonometric functions. This, when you take x equal to 0, this will be tan inverse 1/0, which is infinity. We don't talk about it. It will be 90 degree here, and cot inverse 0. We don't know, that's also. So when the infinity comes into the picture, we don't take that value at all. So x is greater than 0 for this equation, which means that this equation holds good only for the non-zero positive numbers. Okay. And similarly here, cos inverse 1 by x should be equal to secant inverse 1 by x. See, we have the reciprocal of cos, which means that, see, the reciprocal number is with cos. So this will not exist in the cos wave, it is up and down. So either it is greater than 1 or it is lesser than or equal to minus 1. So whenever I have any graph, this is plus 1 and this is minus 1, this is the origin. Here you will have your sine and cos. This will be sine and cos. All your sine and cos values lie between minus 1 and plus 1, and here this part is for cosecant and secant. This part also is for secant and cosecant. I want you to remember like this. So sine and cos will always lie between minus 1 and plus 1. The up and down portions will always be, this is what you have learnt in trigonometry when you are learning for trigonometric functions graphs, okay? And now the same thing holds good for the domain and range. I want you to remember like this. It gets stuck in your head when you think like this. So see, here you can see, because sine is having its reciprocal, sine and cosecant inverse x, cosecant basically x, it lies where it will be greater than 1, it will be greater than or equal to 1, or it is lesser than or equal to minus 1. In between it does not exist. The same thing with cos inverse 1 by x and secant inverse x. Tan inverse 1 by x and cot inverse x, all the positive numbers of non-zero positive numbers will be holding good for this equation. Okay, now how do you prove this? So let us go for proof of this. I'll go to proof. So sine inverse 1 by x I'll call as theta. Okay, and let me call this as equation number 1. Now 1 by x is equal to sine inverse, I transpose that side. So inverse trigonometric becomes trigonometric is equal to sine theta. I shall take reciprocals. So this becomes 1 by x becomes x. 1 by sine is cosecant theta. Now again, theta I'll keep here, cosecant I'll push here. I got cosecant inverse x is equal to theta. See, RHS is equal to RHS, so LHS should be equal to LHS. Equation number 1 and 2 implies sine inverse 1 by x is equal to cosecant inverse x. Then in the same fashion you can prove that cos inverse 1 by x is equal to secant inverse x, tan inverse 1 by x is equal to cot inverse x. Now in the next class, let us continue with the proofs. I just showed you that, see, inverse trigonometric functions will have certain conditions. These conditions are also equally important as these conditions what we are learning, the theorems what we are learning. These are the properties of inverse trigonometric functions. This is the first property what we are learning. We have another 3 to 4 properties which we are going to learn in the next class. With the properties and the proofs, we will complete this and go to the next one. And I am telling you, this inverse trigonometric function is going to form the base for your further continuity, differentiability, and all the types of differentiation and integration. In integration, other than that, you have another chapter called as differential equations. So this will be adopted in all these 3 chapters. Be particular in learning and practicing this chapter questions and the properties.